right, so let's express each repeating decimal as a fraction in lowest terms. So ladies, remember that 0.7 repeated is like 0.77777777, right? And it keeps going, which is also the same as saying it's 0.7 plus 0.07 plus 0.007, isn't it? So, if I found the sum of all those numbers there, then I would find what the decimal is as a fraction. So we're going to do the same thing. We're going to use the fact that we can find the sum of an infinite geometric series as long as my R value is between -1 and 1, right? So on this one, what's my first term?
27.
What is it? 0.7? Oh, I thought you said 27. I started to write it, and I'm like, whoa, wait a minute. All right, and my common ratio is 0.07 divided by 0.7, which is 1 over 10? Or you could even use 0.1, couldn't you? Same thing. All right, so the sum is going to be our first term divided by 1 minus our R. All right, so instead of just typing it in our calculator, because it's going to tell us the 0.7 repeated, right? And then we're going to change it to a fraction. In that case, why didn't we just do it to begin with? Let's just look at it. 7/10 is what? 7 over 10?
Yeah.
Over 1 minus 1/10. Well, that's 9 over 10, isn't it? If I use keep it, change it, flip it, 7 over 10 times 10 over 9, which is 7 over 9. All right, so look at 24. 24 is a little different only because now it's 0.83 repeated, which means 0.83, 83, 83, and it can continue, right? Now be careful because that also means that it's going to be 0.83 plus, now this time I'm going to put 2 zeros because I have 2 numbers already taken care of. So 0.0083. And then I've got 4 of them in that one, so I'm going to put 4 zeros. And we could just keep going, couldn't we?
Why is it 2 zeros?
Because we have 2 things being repeated.
Oh,
so think about it like this. If I lined them up, it would be 0.83, and then I'd have to do, whoops.
So it needs to be 2 zeros because it would.
Right. See what I'm saying? If I lined them up like this, like we used to do with addition and stuff.
So it's the 100 spot. You have to put.
So yeah, that first 0.83 is in the 100 spot. So when I go to do, like I'm going to go ahead and write out that first term, I could write it's 0.83, or I can say, well, that's 83 over 100. And then my common ratio is going to be the 0.0083 over 0.83, which is 0.01. So I'm going to set it up using my formula.
Is there a fraction?
So the sum, yeah, 1 over 100. That's a good idea, the way we're doing it. So I've got my first term, which we said is 83 over 100, over 1 minus 1 over 100.
Wait, why didn't we change the decimal to a fraction?
Because we're going to do it like we did in the previous one, so we're going to do keep it, change it, flip it. Okay? So remember, 1 is 100 over 100. So I've got 83 over 100 over 99 over 100. Keep it, change it, flip it. So keep the top, change it to multiply, flip the bottom. And so because I have 100 on top and bottom, they're going to cancel, so we get
83 over 99.
Yes.
That's
So is 1 equal to 0.9 repeated?
No.
Let's find out. So remember, 0.9 repeated is this, right? Which you can rewrite then as 0.9. And since I only have one thing that's being repeated, it's going to be 1 0. It's 0.09, and then I need 2 zeros. And we could keep going from there.
So if it's 1 decimal place, then it's 1 0. If it's 2, then it's 2.
Right, and then it doubles for the next, you add that same amount each time then, okay? So if it was 2 zeros, then each time I'm going to include 2 extra zeros. Okay, my common ratio. Did you get 1/10?
I'm always having a calculator. I'm checking.
Mm-hmm.
0.09 divided by 0.9.
It does equal 1. Yeah.
Math and memory, 1/10. You're right.
All right, so my first term over 1 minus my common ratio.
Does it not make you nervous working decimals? I feel like I'm gonna get it wrong. I type it in wrong.
And so look what we found.
Does it actually equal 1?
It does equal 1 if you keep going. Remember, this is the sum of the infinite. So if we kept going as far as we could go, it does round to the 1 there. So it's equal to 1.